Hey guys, this is Mr. Bennett, and this is our final video for Unit 8. In this video, we're going to talk about the polarity of bonds and molecules. So when we're talking polarity, the idea here is, you can think of like the Earth. The Earth has a positive pole, negative pole. It's the idea that we're going to create a slight charge, positive and negative. Okay, so to do that, we need to first of all just review the fact that covalent bonds are created when two atoms share electrons, right? But as we talked about in class, the sharing is not always equal. So if the sharing is unequal, okay, we call that a polar bond. If the sharing is equal, we call that a nonpolar bond. Okay, and we can actually determine the amount of sharing. We talked about this in class during one of our WISP chats. We can determine the amount of sharing by their electronegativities, because the electronegativity is a way of describing their attractiveness or their ability to attract electrons. So if one is really good at attracting electrons and the other one is very poor at attracting electrons, then one atom, the one with the higher electronegativity, will hog the electrons. So to determine the polarity of the bond, what you have to do is you have to calculate the difference in their electronegativities. So it's a math problem. Okay. So a nonpolar bond will have a difference of 0 to 0.5. A polar bond will have a difference from 0.5 to 1.7, and an ionic bond will have a difference over 1.7. So in terms of this, think of here, the idea is that you have equal sharing, relatively. Okay. Here it's unequal sharing. Okay, but they're both still sharing. Okay, because they're both still covalent bonds. In the case of the ionic bond, though, it's not equal, and it's actually so far from being equal that it's a transfer of the electron. Okay, and so we want a way of describing this. We want a way of describing in the bond what's actually going on, where the electron's hanging out. And so what we can do is, first of all, verbally we can say that, or with words we can say that the atom with the higher electronegativity or greatest electronegativity will attract electrons more. And then with symbols we can actually use an arrow that points towards or shows the atom where the electrons are moving towards. So we use this arrow to show kind of the movement of the electrons. And we actually modify this arrow slightly. This is just a normal arrow. The arrow that we want to use is an arrow, but it has a little positive tail to it. So let me give you an example. If we had an X and a Y, just two elements, okay, and they're bonded together, and let's say that this is a polar bond, okay, so it's polar, okay, and let's say that in this case Y has the high electronegativity. Okay, so this one has the higher electronegativity. So we would use an arrow. Okay, we would point it towards Y. So it just kind of runs along the bottom here, just underneath our description, our symbol for this bond. Okay, and so the arrow is pointing towards the Y end, and then on the X end we put a little positive. Because the electrons are hanging out more with the Y, they're taking that negative charge with them, which means the X side will be slightly positive. Okay, now we can actually use another symbol to show this as well. We would say that this end of the bond is slightly positive and this end is slightly negative. It's not negative enough to be like an ion, but it's a little bit negative. And so that symbol that I'm drawing there is kind of like a weird S that kind of loops back on itself, and then it either has a negative sign or a positive sign. So if you see these, all it means it has a slightly positive or a slightly negative charge, okay, which is telling you that it's polar. So let's so that's a polar bond. The last topic that we need to talk about in these notes is the idea of what is a polar molecule. Okay, so in a polar molecule, a portion of the molecule attracts the electrons more than the rest. So when we look at the molecule as a whole, the electrons are hanging out in one area more than the others. And so the classic example we use for this is water. If we look at a water molecule, the oxygen has two unshared pairs or lone pairs, and then you have your two hydrogens bonded to it, right? Well, it turns out that the electrons, oxygen is more electronegative than the hydrogen, so much that the electrons are going to hang out on this end, and this end is going to be slightly negative. And since the electrons are not hanging out with the hydrogens as much, this end is slightly positive. If we were going to use that arrow notation, we would draw the arrow pointing towards the oxygen end, and on this end we'd put our little positive. Okay, but this is what we call a polar molecule. And so all that really means is that a region of the molecule has a slight negative charge due to the more electrons, meaning there's more electrons hanging out on this end. Another portion of the molecule is then going to be slightly positive because electrons are not there as much. So electrons aren't hanging out on the hydrogen end as much, so it's slightly positive. Now, that's the definition of a polar molecule. In terms of the shapes that we've talked about, there's really two shapes that create polar molecules consistently, and that would be trigonal, pyramidals, and bent. And if you go back and you look at your notes, remember trigonal, pyramidals, and bent molecules, the thing that they have that tetrahedrals and linears don't have is they have unshared electron pairs. So that's what's going to create their polarity. They have these intense clusters of negative charge, those unshared electron pairs. Okay, so that's the end of our notes, but let's do a little practice together.